All right, we're going to begin with lesson 4.5 on applying properties of logarithms. Going to take a moment. Let's go back just a second. I was playing around with the screen and now I'm not where I wanted. Going to go ahead and expand the screen a bit and let's go back to the starter. So, applying properties of logarithms. We've seen examples already, how we use logarithms for sound intensity. The conversation example, I think, is pretty similar to that. And the parking garage example, I believe, is in your textbook. We'll see a couple of other examples in today's lesson. Properties of logarithms. Notice the stars. That means this page is very, very important. You do want to have these properties written down to be able to reference frequently. You're not going to be given, these aren't formulas per se, these are properties that you're expected to know. So make sure you have them fairly well in your memory, in your repertoire to be able to refer to. So the product property talks about when we have either two variables or we have something we can break up into two factors. So we take the two factors and separate them using addition. We've talked about that with exponents. If you have the same bases, you add the exponents. This is kind of the same idea. The quotient property, if you see you have division, m divided by n. Similar to the exponent property, you're going to subtract. And then the power property is a little bit different. We're not actually multiplying anything yet. We're going to take the exponent and just move it to the front, and so that it becomes n times whatever the log is. So again, take that exponent and move it to the front. We actually do use this quite a bit in real life when we're using these properties as application. All right, let's go ahead and move on to the next screen and take a look at our first example. So how are we going to use these? Right now we're not going to use the calculator. The values are given to you. But we want to use the properties to help us evaluate. Again, evaluate, very key term here. That means to solve it. Give me a number. First thing you want to do, though, is write out the expansion of the properties. So we see a quotient here. So using the quotient property, we're going to subtract. So log of base 3 of 6 minus log base 3 of 5. Plug in the values given to us. Log base 3 of 6 is 1.631, and log base 3 of 5 is 1.465. Plug that into your calculator, or do it by hand if you want to, and we get 0.166. All right, for part B. I'm going to show you an easier way to actually answer a question for part B, but for now, we can look at simpler ones. If we know some basic logs already, we can just go ahead and substitute in. Well, 30, we're only given the logs of base 3 for 5 and 6, so let's use that. Let's break 30 into 5 times 6, and I clear this out. I'm making a silly mistake here. Alright, so we're going to say that 30 is the same thing as 6 times 5, or 5 times 6. It's commutative, so it doesn't really matter what order you put it in. So then we say, okay, our product property tells us that we can add the logs of the factors. So plug in the values. 1.631 plus 1.465, add them together and we get 3.096. So all we did was take 30, plug it into two factors, and then took those factors and added them. All right, for part C, we have log base 3 of 36. Well, 36 is another way of saying 6 squared. So we can rewrite this in that power, and then using our power property, we can take the 2 and put it in front. So now we have 2 times the log base 3 of 6. And we already know the value of that, so 2 times 1.631, multiply that together, and we get 3.262. A lot of times when we're using these expansion properties, it's not using it with the numbers, right? We use these to actually expand or condense, going the other direction, variable expressions. So in the real world, you're not really going to use it like this. You'd solve these problems differently using the calculator, but this gives you an example of why, when we start getting to our variable expressions, why we are going to be able to expand and condense our functions. Let's go ahead and take a look at our first examples. Exercises, so you're given the values and 3 or 4 different problems to solve here. So pause, figure out these answers, and when you're ready, press play to move on. Alright, so here are the answers to the 4 questions. Again, circle the ones you have and make sure you ask about them in class. Also, just to answer some questions so you've had, if you don't feel comfortable speaking up in class, remember, make an appointment with me sometime during the break, after school, before school. That way you can ask your questions one-on-one. But make sure you're telling me beforehand. Sometimes I might be in the middle of something. I might not even be here. But if you let me know, I'll try and make a point of being here for you. So keep that in mind. Okay, moving on. Example 2, expanding a logarithmic function. All right, so here we have a variable expression, obviously, x and y are variables, and we want to go ahead and expand it out. So we're going to use our properties to do that. The first one, I see that this is a quotient, so I'm going to use the quotient property to expand the numerator minus the denominator. All right, but I can take this even further. Notice that the numerator is composed of 2 factors. I have 3 times x to the 4th. So I can take the numerator and break it into, oops, we're going to add those. That should be a plus sign. Alright, so now I'm adding the factors, adding the logs of the factors, I should say, but I still have one more thing to do. Notice I have an exponent here. So, when it says to expand something, kind of like prime factorization, you want to take it down to its most basic parts. So we are moving this all the way out into these most basic parts. And sometimes we might use this to write inverse functions, and sometimes we're using this to get to easier things to figure out with our calculators. But for now, this is the expansion of the function. Okay? Alright, let's go ahead and move on. We're going to go the other direction now. We're going to condense. So let's take these crazy complicated formulas and condense them, which usually means we're simplifying it. Alright, so notice I've got going left to right, I have addition, and then I have subtraction. So I'm going to do the addition first. Again, order of operations, we go left to right. So the addition, the opposite of the addition is we're multiplying those back together. So I'm going to have, well, before I even do that, oh, I've got a coefficient here. So I got to get rid of that first. So let's go ahead and move that coefficient back in so that I have natural log plus natural log. So that's going to give me the natural log of y to the 3rd. And while I'm at it, let's go ahead and do the other one. The natural log of 4 squared. Okay, now we've got natural log plus natural log minus natural log. All the same, no coefficients or anything. Makes it a little bit easier for us. Now I can use that rule of addition and multiply x times y to the 3rd minus the natural log of 4 squared. Well, that's a number. Let's go ahead and put the number in. 16. Now I have just the one operation of subtraction. So the natural log of x times y to the 3rd divided by 16. Now you don't have to put parentheses around this. Sometimes you'll see it, sometimes you won't. But for me, it makes me comfortable to put the parentheses. It reminds me that everything is there together. So if you want to put the parentheses, fine. If not, you can certainly leave it there without the parentheses. But this whole thing, this whole fraction, is what you're going to have to solve for to get the natural log. All right? Yeah. Let's go ahead and erase that. And we're going to take a look at some sample exercises. So just a couple of quick questions. Oops, helps if I actually have the mouse going. Mouse does not want to cooperate. There we go. So here are a couple of sample questions. Number 5, please expand the natural log function. And number 6, condense it. Put it back together again. Take a moment to pause and solve these problems, and when you're ready, press play. All right, so here are the answers to those. Moving on. Now, talking about the change of base formula. Most of you want to use your graphing calculator to solve these logarithmic functions. I mentioned it briefly in the 4.4 lesson, how to do that. Basically, take the log of the big power, oops, whoa, well, we can move that back over here. Oops. There we go. And go back to our pen. So take the log of the big power, put it in the numerator, and divide by the log of the base, and put it in the denominator. So here's the numerator, here's the denominator. You can use either the natural log or the common log, or you can use the natural log. It really doesn't matter. You're going to get the same answer. In fact, let's take a look at an example of that. All right, so example 4, we are talking about the change of function here. So, we want to evaluate log base 2 of 12 using common logarithms and natural logarithms. So let's set it up. We can say log of 12 divided by log of 2. Now I usually type this into my calculator just like this. Log, open parentheses, 12, close parentheses, divided by log, open parentheses, 2, close parentheses. That way it's all one step. That way I'm also not having to worry about rounding decimals too soon. Go ahead and round to 3 decimal places. With our logarithmic functions, that tends to be the most popular way. If you want to, you can use the natural log. There's really no right or wrong here. You can use log or the natural log. It doesn't really matter because you're going to get the same answer. You just pick which one you want to remember. All right, so nice and easy for us. Let's move on. Let's take a look at a word problem really quickly. Average student scores on a memory exam are modeled by the function f of t is equal to 100 minus 12 log t plus 1, where t is the time in months. Notice that our log does not give us a base, so that tells us the base is 10. And t represents the time in months. So if you're asking for a question, that's what we want to know. Average student scores are modeled by f of t, so f of t, or the answer, would be the scores. Use the properties to write this model in condensed form. Well, the only thing we can really condense here is we have this coefficient that we can put in front. 100 is a constant. Not much can be done with that. So 100 minus the log of t plus 1. All right? And we are going to raise that to the 12th power. Not the log, we're raising the t plus 1 to the 12th power. So you may want to put even more parentheses around this to remind you that you have to take the inside first to the 12th power before you can solve it. So plug in your numbers and we get 100 minus log of 3 months, so 3 plus 1 is 4, 4 to the 12th power. Plug that into your calculator and you get 92.7, which we could round to 93. So that would be our score. Score is not given to us in a particular point. So we don't have to worry about a label. Scores usually don't have a label. Okay, take a look at your example. You're going to need to pause because I'm running out of time. So I'm going to have you pause this, solve these problems, and then go ahead and take a look at the answers. So press play when you're ready. Boom, here are your answers. Yay, we got everything done into one quick video. Let's go ahead and wrap that up. I will see you in class.